Welcome students. Today we are going to start the new topic, that is exponents and powers. Before telling you what are exponents, I will discuss what is the need for them in the first case. Sometimes we have to express very large numbers in our calculation, such as the distance between Earth and the Sun, or the distance between two galaxies, or the substances like the weight of the Earth or any other big planet. To express these big numbers, it might take a lot of space. Thus, to minimize the space usage, we write it in the form of exponents and powers so that the calculations look more elegant and we can carry out the calculations in an easy manner. Suppose you have to multiply 125 million with 56,000, or any other two big numbers, or the division of any two big numbers. Then for these solutions we can use exponents and powers to reduce them to a considerable amount so that the calculations can be easily carried out. Suppose we have a number 8, then 8 can be written as 2 into 2 into 2, that is multiplication of 2 carried out 3 times. In the exponent form, it is written as 2 with a 3 on the top of 2. The number 3 here is called the exponent or the index of the 2, and 2 is called the base. The entire expression 2 with a 3 on top is called power. Thus the exponentiation a to the power n is defined as a into a up to n terms. It is not coming from the previous axioms, it is defined in this way. Suppose we have 2 exponent 5, then it means that 2 has to be multiplied with itself 5 times over. Thus exponent tells us how many times the base number has to be multiplied with itself. This process of writing a number in the form of its exponents is called exponentiation. Let us we have a number 36. It can be written as 2 into 2 into 3 into 3. That is as a product of 2 multiplied 2 times over and 3 multiplied 2 times over. That is 2 exponent 2 multiplied 3 exponent 2. The terms exponents and powers are used interchangeably, and we shall be using them interchangeably in our later lecture, but you shall know the basic difference between the two terms. Now since you are done with the basic idea of exponents and powers, let us move to the laws of exponents. The basic rules of exponents are given in the form of table. The first one is product of powers rule. That is, if the powers with the same base are multiplied, then the exponents get added. The second one is division of power rule. That is, if the powers with the same base are divided, then the exponents get subtracted. The third one is power of power rule. That is, if a power is exponentiated to another power n, then the powers get multiplied. The fourth one is negative power rule. If a base is exponentiated to a negative power, then we can write it as 1 over that base with a positive power. Rule number 5 is zero power rule. That is, any base with the exponent 0 is equal to 1. Then we have power of product rule. That is, if a product is raised to power n, then all the elements of that product are raised to that power n. Similarly, power of division rule states that if a division is raised to power n, that all the elements are raised to power n in division. The next one is basis raised to the fractional power or the rational power p over q. If a is raised to the power p over q, then we can write it as qth root of a to the power p. These are the basic rules. I shall be covering their proofs in the next video. If you have any doubts in this video, do let me know in the comment section. Thanks.